All right, let's start with part A. As noted in the question statement, we are trying to find the simplest technique to integrate. And it doesn't mean that we're going to use integration by parts all the time. We can also rely on to the techniques in section 8.1, which is the basic integration rules, essentially. Okay, and you get the algebraic manipulations that we learned, or trigonometric identities that we can apply for certain questions, but we'll decide along the way which way is more convenient. So for part A, we have e to the 1 over x squared, and here is the first observation. If you have 1 over x, the derivative of that is going to be a form of 1 over x squared. In fact, that's going to be negative 1 over x squared. I think for this problem, to go with the u substitution is the best, and the u that I'm going to pick is 1 over x. Okay, so that du will be negative 1 over x squared dx, and you can also see that by converting that into the exponent form, so that you have x to the minus 1. If you use the power rule for differentiation, that's minus 1 x to the minus 2, which is exactly what I have for du over there. Okay. All right, so that this integral here can be converted into e to the u, but with the negative sign. Let me pull the negative sign out, okay, because that comes from 1 over x squared dx is negative du. So here we go. All right, I added the du back. This is now one of the basic. This is a formula in one of the basic integration rules. So I'm going to integrate that as e to the u, because e to the u has the integral a to the u. And I'm going to put a plus c, but in the meantime, I have to go back to the main variable, which is x. So minus e to the 1 over x plus c is the integral of e to the 1 over x squared dx. Okay? So I think that takes care of part A. I'll do the part B in this video. Let's check that out. You have ln x divided by x cubed. You can pause the video at this moment and start thinking about what technique is the most applicable. I'll give you like a few seconds. All right, so what did you come up with? So you have ln x divided by x cubed. Calling u to be ln x is not going to help, because du is going to be 1 over x dx, but I have 1 over x cubed over there in the bottom. Like in the bottom you have x cubed, so how would you sort of like get rid of x cubed in some sense? So I think we should rewrite this as 1 over x cubed ln x dx, and then we should probably rely on to our acronyms, which is L.I.A.T.E, right? So we have logarithmic, inverse trig, algebraic, and trig and exponential. So what sort of functions do we have? We have algebraic, which is 1 over x cubed, right? So let's go back here. We have algebraic and logarithmic. So what that means is, logarithmic is the one that I should call for u, and dv is going to be the rest. So integration by parts is what I am going to use for this problem. Okay. So in other words, I'm going to call. Let me just do the calculation here. I'm going to call u to be ln x, and then dv to be 1 over x cubed dx, to use the integration by parts formula, that u dv equals uv minus v du. Okay, so that's exactly what I'm trying to use for this problem, because there's no other easy way to integrate this integral by the known techniques other than the integration by parts. Okay, all right, so I'm going to look at du here. That is 1 over x dx, because ln x has the derivative 1 over x, and we have to put dx next to that. And then to integrate this, I'm going to rewrite 1 over x cubed as x to the negative 3, and I'm going to use the power rule for integration. Okay, so it's x to the minus 2 divided by minus 2. In other words, negative 1/2. In the bottom you have x squared. Okay, So I think that sounds good for now. So and then I'm gonna use the integration by parts formula. So let me just rewrite this with a different color here. Okay, ln x over x cubed dx. So this is equal to, this part is, by the way, u dv integrated, right? In the integration by parts formula. That's right here. So I'm going to write u times, v, okay? So u equals ln x, v equals -1 half x squared. So there you go. Okay? And then now I'm going to write minus v du, so this is v, by the way, right? So we use blue here because we integrated that, right? So u times v and v times du, so it's -1 half, -1 over 2x squared times 1 over x dx. Here we go. So that should be plus 1 half 1 over x cubed dx. Okay. All right. So now I need to take care of the last integral. To do that, I am going to rewrite this as, again, x to the -3 and use the power rule for integration. Let me continue here. Okay, so it's 1 half x to the -2 over 2. And I'm going to put, by the way, one generic integration constant at the end, so I just didn't want to put all in one. Okay, so -1 over 2x squared ln x plus 1/4 1 over x squared, so 1 over 4x squared. And I forgot a minus sign here, so I'm going to correct that real quick. In the power rule, I divided by the new power, right? X to the -2 divided by -2. So this should be minus, right? So both terms should be minus, and plus a generic integration constant at the end. I think that takes care of everything here. Okay. So the final output is that -1 half x squared ln x. Let me just clean this part and then put it in a box. Okay. So this is the final output for the integral corresponding to the integral in part b, so ln x over x cubed. All right, so I'm going to finish this video right now, and please continue to the next video to see what I'm going to do in part c. All right, bye.